Hello everyone. Today I want to talk a little bit about the table saw and how much I love the particular version that I have. Now, let me just say first that table saws are ubiquitous, of course, in most furniture making shops where I started. And although maybe if you made something very specific, like say a handmade Windsor chair, you might not need a table saw at all in your work. But for most furniture makers who make case goods, that is cabinets, chests, containers, tables, things like that, as well as chairs, the table saw is a super important piece of gear. Now for instrument making it's a little bit different. Most of the time, although we can rip wood on the table saw, an instrument maker would choose a bandsaw for that job. I certainly would choose a bandsaw, and that's to me is the right power tool for resawing. At any rate, I don't have a large table saw in my shop. I have two table saws. I'll show you both of them. This is the smaller one, and this is a Hammond glider trimo saw, an example of an incredibly well-built and well-conceived piece of American machinery. And this is a specific tool that was designed for the printing industry when the printers were using lead type to do most of the printing. So this machine was designed specifically to cut lead, which is a soft and very, very damaging metal that we want to stay away from. In fact, it's been found that lead damages us ever so much more than we first thought. We never thought it was good for us, but now we find out that we really can't tolerate hardly any lead. So let's stay away from that. And the reason I bring this up is that because these machines were designed to cut lead, they are contaminated with it if you buy one from a printer. So in that case, you would want to clean it very carefully with lots of precautions. I don't know, maybe even throw the vacuum cleaner out afterwards. It's terrible stuff, terrible for us. This one I've owned for many years. It's long ago got cleaned and wiped down with solvent, so there's no trace of lead on it. And it continues to make a big difference for us here in the shop. Unbelievably versatile machine, and I often say that the good news and the bad news about this little table saw is the same thing, which is it only cuts square. So if you want to cut square, it's just where you want to be. If you need some other function from a table saw, maybe you need another table saw. I was first introduced to these machines by Michael Gurian. I saw them first at his old workshop in Hinsdale, New Hampshire in the 70s, where he had a whole row of them, each one tooled up for a specific cutting job with a special blade, often ground specifically for that job. Lots of veneer and purfling. He made herringbone purfling and all kinds of sound hole purflings for his own guitar manufacturing, and also to sell to others of us who didn't have the wherewithal to make these complicated purflings. So thanks, Michael, for introducing the field to these great saws. I will note that Michael dismisses them now as finger getters, but I promise you that if you work safely with a table saw, it will not hurt you. So let me tell you first of all the two devices that I can think of that this machine is not equipped with. One is a blade guard, which commonly comes with them, which is a hinged gizmo that comes here. I don't know what happened to this one. It seems to always be in the way. I've never used them. By the way, I've owned many of these. I bought probably maybe 10 of them when I was running the Parker Fly guitar company. And we cut them up and changed them and did all kinds of special jobs with them, including cutting all 6 nut slots at the same time. So that was quite a tool. Anyway, let me show you what this one is. The blade guard is not here. I can't show you that. And then there's another thing that for some reason I either can't find or no longer have, which is a clamp that helps you work on tiny little pieces of material. And it's a clamp that attaches to the table here and here, and it has a toggle lever. Anyway, if anybody has an extra one and they want to sell it to me, I would love to buy one. But it never got used very often. In fact, for little materials, I like to use a scribe or something similar. And with it, you can safely hold down a little piece of material and hold it up against the fence and hold it up against the crosscut fence as well. And then the nice thing about this machine is you can see that you can feed with your hip. So your hands, in this case, can be completely involved in controlling the little piece of material that you're trying to cut. And I'll demonstrate that in a little bit. Here's the fence that's so nice. It's got a quarter nut here, so it's a beautiful bronze casting with threads in it. And because, as I just showed you, you can move it around, you can get it out of the way to make gross adjustments, and then the lead screw will let you dial in. You can see that it has a little pointer, I guess, that can be adjusted here so that it lines up with reality, and then you put your own scale on the tool so that you can direct read whatever it is you like, inches or millimeters. And the reason that you would have to put your own scale on it is that the machine will come calibrated, as you can see here on the fence, in some kind of otherworldly dimensions that we're not even going to talk about, that were unique to the printing industry. It doesn't really matter what they were, but we don't use them. Nobody uses them now. Sliding table, not a lot of travel, but again, for an instrument maker, you can cut some, reasonably big pieces of material. And again, I wouldn't use this for resawing if I didn't have to. Maybe a quickie, but nothing serious. No expensive material would ever get resawn on this machine in my shop, certainly. And then, if we want to look here at the way the blade works, of course it raises with a screw like every other table saw. But unlike other table saws, after you get it to a certain height, this relatively small diameter, it's about 7-inch blade, and arbor start picking up this right-hand part of the table. Now you can see why, because this part of the saw is touching the table over here, or here I guess, the little pad that touches on the arbor housing. And when we move this all the way up, we can see that we can face a piece of wood about 4.5 inches tall and get a beautiful cut. And you'll notice that this is a really interesting stub arbor, and the blade is held on not with a nut on a threaded arbor in the center, but rather with 3 little screws like this. And then I'm not going to bother showing you the detail of this. I have the parts somewhere in a box, but the reason it's called a trim-o saw is that it was designed to first saw through the lead material with the saw teeth, of course, and then protruding in these 3 places were 3 little lathe tools, or something a lot like them, that protruded past the saw by a very small amount, just a few thousandths of an inch, and behaved like fly cutters, and they made a finishing cut. So the saw would part the material and get it ready for these trimming cutters to address the edge of the lead and make a gorgeous surface that was used as the lead blocks were grouped together with clamps in order to print the paper. Something obviously that's a ancient history in terms of manufacturing at this point. So there was a time when these were easy to find and relatively inexpensive. I remember being at an auction where there was, I don't know, 6 or 8 of them in a row, and they went for, the whole row went for $200 or something like that. I didn't know what I was going to do with 8 of them, so I declined to bid. But now they cost maybe, I don't know, I looked the other day, they seem to be available for between, you know, $200 and $1,500. Whether anybody ever pays $1,500 for them is another thing. They're getting harder to find, but they're worth looking for. They're awesome machines. If you get one that's intact, it comes with a special piece of plywood with a bunch of assorted tools and fixtures that are stored on this little rack put on the wall. Here's one of them, which is, of course, a right-hand stop. If you were using materials, you could pick up the length on a stop before it got sawn. And then, in addition to the 90-degree sliding fence, they provide this entertaining miter fence, which is clamped on in this manner here with this little screw that tightens up this part of it, and then it sits in there pretty as you please. I guess they had a specific reason for this. I mean, on the original ruler that came with the saw, there was some kind of mark that said miter vise, so that you knew which way to put it this way, so that it was in the right place. And then this is a clamp, which you can use for something that's this wide or less, I guess. Just by pushing it down, it'll kind of spring and clamp some material to this 45-degree surface. Anyway, interesting and clever, very well made attachment that rarely gets used around here. You can see, I think, how beautifully this whole thing is made. This was taken seriously. These were tools that were designed to last for decades in a production shop sawing metal. While we're here, most of the early saws came, when you bought them, you got a big box of dull and small high-speed steel blades like this. This one came, of course, right from the Hammond Saw Company. Well, you can see it says Trimo Saw right on it. And then, of course, those aren't provided anymore, so now we have, there's a bunch of manufacturers that will supply different saw geometries. So here's a little look at some of these geometries that are available. Now, if I hold the scale here so that it's, you know, pretty much in the middle of the central hole, and then look over here, I think you can see in a close-up that tooth is actually leaning in so-called the wrong direction. In other words, instead of leaning in this direction, which would be positive rake, this tooth, you can see, is disposed in the other direction. It is, and this we call negative rake. So it's kind of more like a scraping cut, and it's useful for certain materials. Here's, by way of an example, another blade that has lots of positive rake. I think you can see that the teeth have positive rake, and this is typical for any woodworking saw, would be positive rake. This negative rake blade might be used for certain metals. It was sold as an aluminum blade and it may in fact work better for aluminum. We do cut aluminum and all kinds of plastic, hard and soft woods, you know, pretty much anything this side of steel gets cut on this saw. You could potentially use it for other materials that were more difficult to cut, but you would probably want to slow the saw down. These days it's not that hard a thing to do. Just a quick demonstration of what the saw is good at. Here's a piece of Douglas fir, one of my favorite materials. I love Douglas fir. Comes from the Pacific Northwest, of course. And so here's the and I think you can see what a splendid cut we got on this. Somewhat difficult to get a good finish like this on other tools. I mean, this is really a beautiful surface, as good as you could ever expect, I think, from a saw. Anyway, that's why we like this saw so much, and it's super useful. We use it for, as I said, not only wood, but plastics, aluminum. You have to be careful that, because it is going too fast for aluminum, but if you use the right wax lubricant designed for the purpose, you can cut thick aluminum plate on this saw without problems of it getting stuck and attaching itself to the teeth. I guess that's all I can tell you about the saw, and now I'm happy to demonstrate a couple of very useful things that the saw will get done for us here in the shop. Hammond Table Saw. So today we're going to look at the Hammond saw and a little job that I like to do on it. First, a disclaimer, certainly there's a lot of other ways to do this. The job is a mask to protect the fretboard while we're working on the frets with files and abrasive materials. And there's a lot of ways to skin this cat. One way is to use a single mask, handheld, on whichever side of the fret you're dealing with. This is nice to have it on both sides when you're sanding, so you don't have to worry about making a mark, an unwanted mark on the fretboard. And then, of course, you can go buy these, relatively inexpensive, from suppliers. And certainly it's not the only way to make them. For example, you could cut up pieces of sheet metal like this and put it all together with solder if you wanted to construct a mask instead of cutting a slot. But I don't know, this is how I do it, and I like how it comes out. They don't take me very long to make. Here it is. I'm going to show you how this works. So there's a piece of 1/2-inch plywood that's securely clamped to the saw and covering up the blade. So we're going to raise the blade up through this support material, which we'll certainly need since we're cutting such thin. Again, this is 10/1000ths thick brass shim stock. So first we'll drive the blade up through this piece of support material, and we'll stop when the blade is up the right width of the cut. Here we go. So we'll just eyeball that and just make sure that we have exactly what we want. Looks just right to me. Okay, and so our next thing is, looking at the pointer here, we see that happily it's landed on a whole number. So we'll just regard 8 as our stopping point. No need to set 0 since it's lined up perfectly with 8. So we'll lower that blade and check here that this is in the right position in this direction. And it's slightly misaligned, but I'm going to call it close enough. The length of these things is arbitrary. Oh, this is a little shorter than the one that I have. It's going to work out fine. Okay, so now this is positioned by the fence and the stop here. And then we'll put a sacrificial piece of wood on top. So that our thin piece of brass shim stock is nicely clamped and fully supported everywhere. And now we'll drive the blade up through it. Well, we're going to call that a good part. It made a little bit of a mess here on this end with vibration in the brass. Of course, this blade is not optimal geometry to cut brass, so that's an issue. But I think we've got a good part here, and the length is about right, and it's pretty close to being centered, so that's the part. We'll go ahead and do the rest of them, and have plenty of these in the drawer for when this chore comes along. Of course, we want to do everything we can to make sure that our fretwork is so good that we don't need a lot of reworking. Okay, so this one I fed more carefully, and you can see we got a much better part than this first one we did. So I put a little bit more force on the clamp, and I fed more slowly, and now we've got just what we want. So now it's time to throw the rest of them in there, and we'll have plenty of parts for a while to come. Anyway, this is just a demonstration of some of the nice features of this pretty little table saw that can do things that we might not normally call upon a table saw to do. Today we're back at the Hammond saw, and of course it doesn't have to be a Hammond saw for what we're about to do, but I'd just like to show you my take on cove cutting, which is an old trick in which you have a fence that's not parallel to the travel of the blade, and you move the wood at an angle in such a way as to produce, you can see it here pretty clearly, a nice curved hollow surface. It's a fantastic technique, a little tricky, but it can be safely done on the table saw if you take it easy and plan carefully. And I'm going to show you how I do this. Now, before we leap off into this cove cutting world, I'll just say that cove cut is a cool way to make a tool handle. And here's one of my favorite fretting tools, which is a chopped up version of this single cut file, this triangular file. We'll get into that later. And it's glued to a wooden handle, again, like this, with a cove cut in it, and it gives good service and it's easy to hold on to, very pleasant tool to work with, and moves extra fret material very efficiently. Love this. First, we're going to look into cove cutting, and later we'll put the whole tool together. We have to decide what angle we're going to make, and of course, the closer you get to the direction that the saw is traveling, the more curve you're going to get in the concavity. And then conversely, as we move in this direction, we will get if we go all the way across, we get the arc of the saw blade itself, which sometimes can be useful. But normally it's somewhere in between, so I think we're gonna try and guess at a thing like this. And I'm an eyeball person, so I tend to try and set it up this way, try and imagine what the blade is going to do just by looking at it in this way. And then when I think I'm in the right neighborhood, I'll keep the table from moving with this clamp on the left side of the table. And then we'll clamp down our aluminum fence. This is just a piece of aluminum stock, flat stock. This is, not really a straight edge, but it's straight enough for this work. And it's going to work great as a fence. Clamp it securely at both ends. And we'll take a test cut, see if we're happy with the angle that we've chosen, okay? All right, so power up. I will raise the blade a little bit. And we can try and see whether we've put it in the right place for the part we're trying to make. That's pretty much what I'm looking for. So I'm gonna have a look at the height here. Which says 14, so it doesn't have to say 0. We'll we'll just remember that it says 14 on the height of the blade. And we're going to go ahead and run the whole piece on both sides, flipping it over so that we refer to the same side. Okay, back down to our initial small cut. Flip it over. So you can probably imagine that the cutting forces are going to try and push the wood away from the fence. It's very important that the fence is clamped very securely and that you maintain excellent pressure against the fence so that it can't deviate. From the guiding surface of the fence, okay? Another little feed. Better to take your time and go slow. Lee. This will be our last cut. Oh, and I might mention that now's the time to decide whether you want to feed fast or slow. If you feed fast, you get a little bit more texture on the surface. But I think what we're getting is fine. We're going to just keep on feeding this kind of medium slow way, and we'll get the surface we want. Well, I normally would have had my mask on for this cut, but since I'm talking to you, it didn't make it. Anyway, you can see the little saw marks. Here, let me set this down. You can see the little saw marks that help make an easy surface to grip. So Nice to have scrap curly mahogany around to make good tools out of, huh? One of the benefits of instrument making. So that's a simple 1, 2, 3 on cove cutting on a table saw, and next time we'll finish the tool.